This is Calculus AB 2.4 Rates of Change, page 1. We're going to start off looking at a data table here. We're driving from Sandburg to Lockport. Mile number, it's kind of the last two digits of the odometer on your car. And time that we leave school, 2:30 in the afternoon. Halfway home, my home. In Homer Glen at 2:46, and it was 8 miles. Lockport all the way home at 2:56. So, find the average rate from Sandburg to Lockport. Average rate is going to be change in distance divided by that change in time. So distance from Sandburg all the way to Lockport, 25 minus 10 over 256 minus 230. And we'll get 15 over 26 units. This was miles per minute. And because those units are awkward for us, if we think about driving, let's go ahead and change this to miles per hour. So we have the miles, we'll need to multiply by 60 minutes in 1 hour so that those units cancel. And when you multiply this out, you will get 34.615 miles per hour. That's the average rate from Sandburg to Lockport. Does that mean that we were traveling at 34.615 miles per hour the entire way? You know that's not true. Absolutely not, because at some point there were stop signs, and at some point must have been going faster than 34.615. The average 34.615. And if we look at the average rate from Homer Glen to Lockport, again, same thing. Homer Glen to Lockport, 25 minus 18, 256 minus 246. Again, that's 7 miles. No. Yeah, per, minute. And if we multiply by 60 minutes in 1 hour, we will get 42 miles per hour. And that makes sense. Sandburg to Lockport, there's a lot more traffic. Sandburg to Lockport average at 34.6, and Homer Glen to Lockport. So the whole thing had an average of 34, but just this little bit, 42, which makes sense because that last bit going from Homer Glen to Lockport, it's a lot more country roads, less stop signs, less traffic, etc. For a specific example, change in distance over change in time. However, if we want to look in general and talk about the average rate of change of a function over an interval from A to B, that's going to be that change in y over change in x, which is f of b minus f of a all over b minus a. And you should recognize this. Average rate of change of a function is slope of a line. Okay, taking just kind of a little bit of a detour here, and then we'll come back and we'll talk about this average rate of change of a function again. But first we need to talk about slope of a tangent line. And I need to know if you remember tangent lines from geometry. A tangent line from geometry, recall, was a line that just skated right on the edge of a circle. And it intersected that circle just at one point right there. And this was a tangent line. Do you recall the name of this line that went through the circle and intersected that circle at 2 points? That was a secant. And you talked about tangent lines just as related to circles. Curves can have tangent lines as well. And it's the same concept as it is for a circle, is that that line, that tangent line, skates right along the edge of a curve. So there's a tangent line right here. It's skating right along the edge of the curve and intersects just at that one point. There's a tangent. Just like a circle has many tangents, a curve has many tangents. And here's another tangent line sitting right here. And these spots where that curve intersects that tangent line, or where that tangent line hits that curve or skates right along the edge, those are called points of tangency. All right, now there's one other situation I need you to take a look at. If we look right here, this line that I'm drawing intersects the curve at 2 places. Actually, and if I extended it, it would hit a 3rd point over here, and then assuming that this continues down, it would hit a 4th point. And visually, what I need you to see with this is that the difference between this point right here and this one right here. This one is a point of tangency right here because that curve is just skating right along the edge. That is a point of tangency. This out here where that line crosses through the curve right there, that is not a point of tangency. And it's important for you, one, to see the difference and then understand the difference. Tangent lines kind of skate right along the edge, intersect the curve at one point. Intersecting here, yes, it does intersect the curve, but it's crossing through. It's not skating right along the edge of that curve.